Chapter 1, steady flow in pipes. So for topic 1.1, laminar flow through circular pipe. So now kita tengok laminar flow dalam pipe yang bulat. Okay. Okay, so here we have deal with analysis of pipe flow running under steady and uniform condition. Okay, what do you understand by steady? Okay, steady and uniform. Okay, uniform. As uniform, we have the fluid flow in which all the conditions at any one point are constant with respect to space. Okay, what does it mean by constant with respect to space? It shows that, okay, for example, when we have the pipe, so this is the pipe, and then there are flow in, Q in, okay, and then Q out. Okay, so at any point of this along this pipe, okay, at any point, like kira dekat center of the pipe or at the boundary of the pipe, okay, the molecules that flowing have the same velocity with respect to space. Okay, with respect to space, meaning at any point, like kira di tengah pipe ataupun di tepi-tepi border pipe ni, because kita tak ada halangan dari segi border. Okay, basically where we have the flow that moving at the boundary of the pipe, border of the pipe, kita ada friction, geseran. Okay, friction yang terjadi disebabkan pelanggaran molekul air di antara molekul air dan juga pipe punya for example, kalau ada dibuat daripada besi, so besi tu akan menghalang molekul tu dari bergerak kan, laju. Okay, so bila kita ada steady, kita ada uniform flow, meaning itu tak berlaku, tak ada beza lah antara center of the pipe dengan boundary of the pipe. Okay, dia punya flowing of the molecules. And then for steady flow, we have the fluid flow constant. Okay, fluid flow constant with respect to time. With respect to time means that when the flowing of the water in this pipe, for example at time 1, so it is like 10 meter per second. So at time 2 yang keluar dekat Q out ni pun same, that is 10 meter per second. So means that there are no changes, there are no decreasing or increasing of the flow rate. Okay, that is the steady flow, constant with time. Okay, and then we move to the laminar flow in circular pipe under steady and uniform condition. So we apply the momentum equation, and then relationship between the shear stress and velocity gradient is utilized to obtain the velocity within the cross section. So when there are no slip condition meaning yang tak ada apa-apa friction ataupun halangan lah disebabkan oleh boundary of pipe tadi. So the velocity of the fluid in contact with solid equal to velocity in the solid boundary. Okay, so maknanya when kita tengok, this is the view from the side view. Okay, the side view kita tengok daripada tepi pipe. So we have this is the boundary of the pipe. Okay, boundary of the pipe. Okay, boundary of the pipe. So kita ada flow of water. So this kat sini bila dia ada geseran dengan boundary of the pipe, so flow yang mengalir kat sini lebih rendah dia punya velocity as compared to the flow yang mengalir di tengah-tengah ni. Sebab tu di tengah ni kita label as U maximum, velocity yang maksimum berlaku di tengah-tengah pipe. Okay, kemudian nanti dia sampai kat boundary ni balik, velocity dia makin kurang sebab ada geseran dengan friction oleh batang pipe ni. Okay, And then we have this view. This view is, for example, when we have the pipe. So we look at the pipe from this direction. Di mata ya. So kita tengok pipe, kita nampak dia punya cross section kan. So inilah cross section dia. So we have the radius R. So we label as R, capital letter R. Radius measured from the center of the pipe to the boundary of the pipe. Okay, now we have a small letter R from the center of the pipe to the any point of the U tu, molecule yang kita nak measure tu. Okay, velocity molecule yang kita nak measure tu di mana? Katakan dia point X, so R is measured from the center to the X. Okay, and then the differential of R, the symbol differential of R is the distance from the boundary to the X. Okay, molecule yang kita nak measure velocity dia. Okay, so this is the annulus. That is the part of the fluid flowing in the pipe with radius R. Okay, so when we have R, so R is, capital letter R is measured from the center to the boundary. So the flowing of the maximum flowing lah. So measure from the center of the pipe to the any point dekat X contohnya. Okay, so measure with R. Okay, and then we have the friction. Okay, friction means that when we have flowing of pipe from the upper direction to the lower direction, so definitely we have a friction yang akan in the opposite direction, menentang arus air itulah, supaya itu yang namakan dia tau, shear stress, friction. So it is a geseran lah. Okay, force yang menolak, yang menghalang dia untuk bergerak ke bawah. Okay, so we also have the weight of the pipe, of the weight of the water molecule. Means that air pun ada berat. So berat itulah akan menghalang dia untuk bergerak towards the gravity direction. Okay, and then we also have some elevation. So elevation is basically kalau pipe tu kita memang akan design dia macam ada satu slope lah. So slope ni akan to encourage the flowing, okay, of the water by gravitational force lah. Okay, and then since we have the elevation, so we definitely have the theta. The theta is the degree lah between the depth to the pipe. Okay, and then we have, okay, so that's all. Okay, so we have the fluid density. Okay, rho. So rho is for molecule of water, rho is 1000 kg per meter. Okay, kilogram per meter cube nanti. Right, okay. So density is volume, mass over volume, kan? Okay, mass kilogram per meter cube. Okay, so density of water, and then water equation applied to the annular element and summing the force and equating them to the rate of change of momentum. Okay, and then we also have force in the ratio of motion, okay, due to the pressure, due to the shear stress, and due to the weight. Force, okay, force maksudnya daya, okay, force yang menolak air tu. Okay, so dia disebabkan oleh pressure dia lah, pressure, and then disebabkan ada geseran daripada pipe, and then disebabkan weight of the water. Okay, and then force also may also happen due to opposite direction, due to the pressure and due to the type of shear of the boundary. Okay, friction of the boundary. Okay, so pressure. So for the first formula, we have pressure. Pressure determine, the basic formula for pressure is P equal to F over A. So force over area of pipe. So therefore, when we have P times with the we need, okay, when we want P, when we want to measure F, so the P times with A. Okay, so P times with A is, okay, so circular pipe, so area is pi r square. So disebabkan kita ada dua area, force pressure from towards pressure from opposite direction pun kita ambil kira, so that's why kita ada dua sini, dua force to the area. Okay, so pi r square, okay, so we get P 2 pi r square. Okay, and then when we measure the force due to pressure plus the differential in opposite direction, so again we have P plus, okay, so 2 pi r square again. And then we also have the force due to shear force. So shear force we measure by tau over area, okay, area of the pipe. So area of the perimeter. So perimeter of pipe is measured by 2 pi r, kan, perimeter of circular area, perimeter. So we have tau here. Okay, so that's why 2 pi r times with the direction of x2. Okay, and then we also have the shear force in opposite direction. So kita terpaksa tambahkan lagi dengan, tadi kita dah ada sampai tau. Okay, tadi kita dah ada tau pi r ni kan, sampai sini tau pi r. So disebabkan kita ada opposite direction, kita ada 2 pi again. So kita ada 2 kali lah area. Okay. And then we also have force due to the height. Height is weight. Okay, weight is due to the mass. Okay, so density times volume times gravity. So we have the weight is equal to mass times gravity. So mass is the density times area, volume. So tadi kan kita ada density equal to, density punya formula apa? Mass over volume. So that's why kita nak mass kan, mass. So that's why kita ada density times with the volume. So density times volume times with gravity. So we have okay, so we have this mg. Okay, so area, 2 pi r square. Okay, area is, okay, so again volume of the rho times density, 2 pi r square, 2 pi r square, volume of cylinder. Okay, volume of cylinder. So kita tahu volume of cylinder berapa? Dia punya formula 2 pi r square lah ni area kan, circular punya area pi r square times with the dx. So that is the volume of cylinder times with the rho remain here, g is remain here. So kita simplify dapat this equation. Okay, and then we also have due to the sin theta. So kita akan dapatlah formula equation for yang ini. Okay, so adalah dia punya apa nama sin cos theta punya rules yang you kena darab bahagi, dan you dapatlah yang ini. Okay, matematik lah itu ya. Saya tunjukkan kat sini macam mana dia dapat yang distinct. Okay, you tahu equation 5, this is the W sin theta, equation 5. Okay, so for momentum equation, sum up all the force, so mesti dapat 0. Means that equation 1 to equation 1 minus equation 2. Equation 1 tadi disebabkan oleh apa tadi? Force yang bergerak to the downward kan, okay, ke bawah. Okay, force yang tolak dia ke bawah. And then equation 2 force yang opposite direction, that's why dia tolak ke sini. Okay, and then plus equation 3 because of shear force kan. Okay, shear force yang menolak dia ke bawah. and then equation 4, shear force yang menolak dia ke atas, menghalang dia daripada tu ke atas. And then equation 5 disebabkan oleh the weight of the water, kan? So dia turun ke bawah. Okay, so ni lah dia menolak, and then dia menghalang, and then ni dia again dia tolak, shear force menolak, and then shear force yang menghalang, and then weight yang menolak dia ke bawah. So all these thing 5 equation we sum up, and then we must get 0. So that is for the momentum equation. Okay, and then we substituting the W. Okay, so with the force tadi and sin theta, and then they cancel out the term, the out term, and then it will yields. Okay, so rho gz plus pressure, piezometric pressure. So apa yang kita dapat? Kita dapatlah piezometric pressure punya formula, iaitu pressure plus rho times gravity times height z. Okay, it is independent of R, so this expression can be integrated with respect to R. So kita integrate of this formula, and you get the R square over 2. Okay, so dapat this thing, okay, equal to 0. So substituting values at the center line where R is 0 and C is 0. So where R is 0, and then C is 0, so therefore we get this formula.